Alright, so in this video, like I said, we are going to talk about what? SCID, severe combined immunodeficiency. Severe combined immunodeficiency. Severe combined immunodeficiency. So basically, in this disease, both your humoral immunity and your what? And your cell-mediated immunity are compromised. Both your humoral immunity and your cell-mediated immunity are what? They are compromised. Okay. Now, what causes? Remember, in all your disease you're writing, you must put introduction, put your cause, put all those stuff. Okay, your management, whatever, put them. So, as a word of introduction, I can say that severe combined immunodeficiency is a genetic disorder that is characterized by let's say I don't know the word to use now, but both the B cell and the T cell immunity are compromised. So you're having low immunity. The person is susceptible to what? To any kind of infection. It's more like HIV, but not HIV. But what I'm trying to say is that both the B cell immunity and the T cell immunity are compromised. Both the B cell immunity and the T cell immunity are what? Compromised. What is the cause? What is the cause? That's the next thing you have to write. The cause. What causes it? Lack of what? Adenosine deaminase enzyme. Adenosine deaminase enzyme. You can see it here. I told you guys that time now. I said you should take note of this enzyme. Take note of this enzyme. Very, very, very important. Very, very, very important. Lack of that enzyme will cause waiting severe combined immunodeficiency. So how will it cause it? That's what we want to see. How is it going to affect both your B cell and your T cell? Okay. How is it going to affect it? So just know that the cause is what? Lack of adenosine deaminase. Adenosine deaminase. Okay. So due to lack of adenosine deaminase, adenosine will what? Will begin to what? What will happen to adenosine? It will what? It will accumulate. Is that not so? It is going to accumulate. So due to the lack of adenosine deaminase, adenosine will what? Will accumulate. When adenosine accumulates, it is going to form, adenosine is just what is adenosine? It's a nucleoside, abi? If I add a phosphate to it, sure I can get AMP, abi? Then I can also get within ATP, abi? I can also get within DATP. If I modify the sugar, I can get deoxy ATP. So what am I trying to say? Once you are having high levels of this accumulating, it will lead to high levels of ATP and high levels of what? Deoxy ATP. High levels of ATP and high levels of deoxy ATP. Now, when you have high levels of ATP and high levels of deoxy ATP, this is the main thing I need you guys to understand. It will inhibit this enzyme. The enzyme is called ARO enzyme. Ribonucleotide reductase. That time we usually call it ARO. So this enzyme will be inhibited. This enzyme is the enzyme that is responsible for converting your ribonucleotide to deoxyribonucleotide. I get my point. This enzyme, ribonucleotide reductase, convert ribose sugar to deoxyribose sugar. So for example, even if you are having something like CTP, if you want to get deoxy CTP, you will need ARO enzyme. So due to the high levels of ATP and the high levels of deoxy ATP that has been formed, it will now lead to inhibition of ribonucleotide reductase. I can repeat it in like 100 times just for you to get it. It's very, 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 very important. Due to the high levels of ATP and the high levels of deoxy ATP, it will now lead to what? It will lead to what? Inhibition of ribonucleotide reductase. So due to if ribonucleotide reductase is inhibited, it means that all those your nucleotide like your CTP, you cannot convert it to deoxy CTP. Another one again, your TTP, which is thiamine triphosphate, you cannot convert it to deoxy TTP. I get my point. Which other one again? Your GTP. You cannot convert it to deoxy GTP. So what am I trying to say? The conversion of ribonucleotide to deoxyribonucleotide will be hampered. And you know that deoxyribonucleotide is what we use for what? For DNA synthesis. I get my point. It's what we use for DNA synthesis. So it means that the cell cannot synthesize their DNA proper. All those B cell and T cell, they can't synthesize their DNA. If they cannot synthesize their DNA, it means that they cannot do what? They cannot do replication. Remember, those cells are replicating fast. So they cannot do what? Replication. If they cannot do replication, it means that both the B cell and the T cell will be affected. They can't do their immunity function. They can't do those stuff again. Are you getting it? All right. So that is it. So let's continue with the flow chart. This will lead to inhibition of what? Ribonucleotide reductase. So due to lack of ribonucleotide reductase activity, it will lead to what? Low levels of what? Deoxy what? CTP, deoxy TTP, deoxy GTP. Okay. Now this will now lead to what? Sorry for that. This will lead to what? Decreased DNA synthesis. I get my point. Are you seeing this thing? You see it too. It will lead to what? Decrease in DNA synthesis. Then it will now lead to it will affect both the B cell and the T cell replication, meaning they can't divide. Then it will now lead to both. The reason why we are calling it combined is because both the B cell and the T cell are affected. So it will now affect both type of humoral immunity, both B cell immunity, which we usually call humoral immunity, and the T cell immunity, which we call cell-mediated immunity. So if you are asked, how does adenosine deaminase deficiency cause severe combined immunodeficiency? So basically, if somebody lacks adenosine deaminase enzyme, it means that the person cannot convert adenosine to inosine, means adenosine will accumulate. High levels of adenosine will definitely be converted to ATP and deoxy ATP. This will now inhibit ribonucleotide reductase. If ribonucleotide reductase is inhibited, it means that you are going to have low levels of CTP, deoxy CTP, deoxy TTP, deoxy GTP. Then there will be decreased weight in DNA synthesis. Then both the B cell and T cell will be affected. Hence the name severe combined. Both combined mean both the B cell and T cell are affected. So the person will be having serious complication. Let me see if I have any other thing here for you. Okay, there's nothing else. So that is it. For the treatment of this thing, how do you treat it? Let me just put it here. Are you seeing it? All right. For the treatment of this thing, what we do basically, we use gene therapy. It's one of the ailments in which gene therapy is being applied. Gene therapy, that's what we use. That's what we use basically. Okay. So that is it. That is it about a severe combined immunodeficiency. All right. In the next video, I think we are going into pyrimidine. Okay. Thank you.